Here's part 2 of your Chapter 2 study guide. For number 12 and 13, you are writing your answer in standard notation. So I write down the coefficient, and I put my pencil on the decimal, and the exponent tells me to make the 6 positions, or 6 powers of 10, greater. 1, 2, 3, 4, 5, 6. Then I fill in those spots and rewrite this number, putting in my commas, and that is my final answer. For number 13, same process. I put my pencil on the decimal, and I know it's -2 for my power of 10. So we're going to move to the left 2 positions, fill in, and then rewrite the final answer, 0.0983. The weight of Mercury and the weight of Mars, we're looking for the combined weight of them. That means we're going to add them together. Now you can use the calculator in scientific notation mode. Again, to access that, it's second function DRG. That's where the science and English mode is above it. And you would make sure you use grouping symbols around your quantities. If I did this by hand, I can just line them up because they both have 10 to the 15th power. So I would keep 10 to the 15th power, and then I would just add this up. And then I'd have to move this decimal one place and then change my exponent. So then when I move my decimal, this exponent becomes 16. So my final answer is 1.2689 times 10 to the 16th power. And again, it's okay if you use your calculator to do the combined amounts. Okay, the next one, when I first read it, is pretty confusing. Let me read this again. Planet Purog is 9.99 times 10 to the 5th kilometers away from planet Kroot, and planet Cicerab is 4.23 times 10 to the 5th kilometers away from planet Yelv. How much farther away is Purog from Kroot compared to Cicerab and Yelv? I'm going to draw a little sketch so I can help kind of visualize what's going on here with the planets. Okay, here's my planet Purog and my planet Kroot, and it's 9.99 times 10 to the 5th away. And then here's a little visual of planet Cicerab and planet Yelv, and that distance is 4.23 times 10 to the 5th. Now the question asks, how much farther away is this distance compared to this distance? So to me, how much farther away that is, I'm going to subtract those two to find the difference between them. So again, put your calculator in scientific notation mode if you want. Since these both have the same power of 10, I can just subtract them the way they are and keep the 10 to the 5th power. And I get an answer of 5.76 times 10 to the 5th power. Okay, short response number 2. An apple has 9.5 times 10 to the 1st calories, while an orange contains 4.5 times 10 to the 1st calories. How many times greater is the amount of calories in the apple compared to the orange? We've seen this several times. How many times greater is a division problem? Put the larger amount in the numerator. Okay, get an answer of 2.1 repeating in times 10 to the 0 power. And remember, 10 to the 0 power is just 1. So my answer is about 2 times as great, or 2.1 times greater. Okay, your final question. Plankton are microscopic organisms that drift in the water. A whale feeds by swimming through masses of plankton with its mouth open. A single whale can eat about 1,277,500 kilograms of plankton in a year. Invertebrates eat about 3,521,000,000,000 milligrams of plankton each year. Write each of these amounts in scientific notation. Okay, so our whale, 1, 2, 3, 4, 5, 6. My exponent is 6. And the other amount, 3.521 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now it's important to know that the first one was kilograms and the second one was milligrams. Now we have to convert each of those to grams. Okay, so you remember our saying, however you want to remember it, King Hector died by drinking chocolate milk, or whatever you do to remember it. We're going to the basic unit of grams. So the first one we're going from kilograms to grams. 1, 2, 3 powers of 10. And we're moving that back. So this would be multiplying this amount by 1,000, or 3 powers of 10. So I would just be, a shortcut would be just to add 3 powers of 10 to my original value. So that becomes 10 to the 9th power. Now let's look at the other one. We're going from milligrams to grams. So now we're going from milligrams back here, and we're going to go back to grams. So we're going to divide by 1,000, or 3 places back, so we're going to take 3 away from this amount. Now both of those amounts are in grams. The final question says, write the combined amount of plankton eaten each year by both groups in scientific notation. That means we're going to take these two amounts and add them together. Now they both have the same power of 10, so I can just add the coefficients and keep 10 to the 9th power, or use your calculator. So my final answer when I add them together is 4.7985 times 10 to the 9th power. That is the total amount of plankton in grams eaten by both groups each year.